We are discussing the unit 2. Good afternoon, friends. So we are discussing the unit 2. Its name is linear differential equation of higher order constant coefficients. The topics in this unit is definitions, homogeneous and non-homogeneous, complementary function, general solution, particular integral, Wronskian method of variation of parameters, simultaneous linear equations, applications to LCR circuits, problems and simple harmonic motion. And before knowing about the unit 2, and first we know about the complementary function. Complementary function, it is the differential equation. It is the concept came from the homogeneous linear differential equation. The homogeneous linear differential equation, its form is dny by dx power n dk1 dn minus y by dx power n minus 1 plus k2 dn minus 2y by dx n minus 2 plus kn minus 1 dy by dx plus kny is equal to 0. After knowing this differential equation, first we find its auxiliary equation. To know about the auxiliary equation, first we write d is equal to d by dx, d square equal to d square by dx square, dn is equal to dn by dx power n. By doing that, we have dny plus k1 dn minus y plus k2 dn minus 2y plus kn minus 1 dy plus kny is equal to 0. By taking common y, we have d power n plus k1 d power n minus 1 plus k2 d power n minus 2 plus kn minus 1 d plus kn of y is equal to 0. In obtaining auxiliary equation, we must remember y not equal to 0. When y not equal to 0, by that d power n, k1 d power n minus 1 plus k2 d power n minus 2 plus kn minus 1 into d plus kn is equal to 0. Now replace d by m, we get m power n plus k1 m power n minus 1 plus k2 m power n minus 2 plus kn minus 1 into m plus kn equal to 0. The equation in m is called auxiliary equation. The roots of auxiliary equation give the complementary function. The complementary function depends on the roots of auxiliary equation. If the roots of auxiliary equation m1, m2, m3 are real and different, then complementary function is c1 e power m1x plus c2 e power m2x plus c3 e power m3x. If the roots of auxiliary equations are real and equal, then if m1 is equal to m2, then complementary function is c1 plus c2x e power m1x. If m1 is equal to m2 is equal to m3, then complementary function is c1 plus c2x plus c3x square e power m1x. If one pair of roots are conjugate complex, then is equal to m is equal to alpha plus or minus I beta, then complementary function is e power alpha x c1 cos beta x plus c2 sin beta x. If two pairs of roots are conjugate complex numbers, then alpha plus I beta plus gamma plus I delta, then the complementary function is e power alpha x c1 cos beta x plus c2 sin beta x plus e power gamma x c3 cos delta x plus c4 sin delta x. Here, by conclusion, we understand that the solution of homogeneous linear differential equation equal to its complementary function. Now, we are discussing about the non-homogeneous linear differential equation. Its form is dny by dx power n k1 d power n minus y by dx power n minus 1 plus k2 dn minus 2 dx power n minus 2 plus kn minus 1 dy plus kny is equal to qx. Now, here also we can find the auxiliary equation. So, before knowing the auxiliary equation, we can write the corresponding similar equation to this non-homogeneous linear equation that is given by dny by dx power n k1 dn minus y by dx power n minus 1 plus k2 dn minus 2 by dx power n minus 2 plus kn minus 1 dy by dx plus kny is equal to 0. We are writing d is equal d by dx, d square equal d square by dx square, dn is equal dn by dx power n. Then we have dny plus k1 dn minus y plus k2 dn minus 2y plus kn minus 1 dy plus kny is equal to 0. Plus now we can write the dn is equal to now we can write dny is equal to, taking common y, dn k1 d power n minus 1 k2 d power n minus 2 kn minus 1 into d plus kn of y is equal to 0. Since y not equal to 0, then dn k1 d power n minus k2 d power n kn minus 1 dn plus kn equal to 0. Replace d by m, we get m power n plus k1 m power n minus 2 plus k2 m power n minus 2 kn minus 1 m plus kn equal to 0. It is called auxiliary equation. The roots of auxiliary equation give complementary function. Therefore, solution of non-homogeneous linear differential equation equal to complementary function plus particular integral. Complementary function c of pi is equal to particular integral. Now we are knowing the rules about the particular integral. We are knowing the rules about the particular integral. We are writing the particular integral is your particular integral of e power alpha x. Here we are writing the non-homogeneous linear differential equation in compact form. Fd of y is equal to e power alpha x. Here the particular integral of e power alpha x is equal to 1 by f of d into e power alpha x. To know the value of this particular integral, replace d by alpha in f of d. Then we have f of alpha. If f of alpha not equal to 0, then particular integral is 1 by f of alpha into e power alpha x. If f of alpha 0, f dash alpha not equal to 0, then particular integral is x into 1 by f dash alpha into e power alpha x. F of alpha 0, f dash alpha 0, f double dash alpha not equal to 0, then particular integral x square into 1 by f double dash alpha into e power alpha x. Then we come to know the meaning of the particular integral of sin alpha x. Particular integral of sin alpha x. So we are writing the particular, we write the differential equation with sin alpha x. It is given by fd of y is equal to sin alpha x. Here the particular integral is the sin alpha x. Then the differential equation is fd of y is equal to sin alpha x. In that case, we write fd as function of d square and replace d square by minus alpha square in f of d square. Then we come to the, if f of minus alpha square not equal to 0, then particular integral is 1 by f of minus alpha square sin alpha x. If f of minus alpha square is 0, f dash of minus alpha square not equal to 0, then particular integral is x into 1 by f dash of minus alpha square into sin alpha x. If f of minus alpha square 0, f dash of minus alpha square 0, f double dash of minus alpha not equal to 0, then particular integral is x square into f1 by f double dash of minus alpha square into sin alpha x. We are discussing about the particular integral of e power alpha x into v, where v is equal to sin alpha x cos alpha x. Then we know that the particular fd of y is equal to e power alpha x into v. Then particular integral is 1 by f of d into e power alpha x into v. By exponential shifting, we have e power alpha x into 1 by f of d, e power 1 by f of d plus alpha into v. Particular integral of x power m into v, where v is equal to sin alpha x or cos alpha x. We know that fd of y is equal to x power m into v. V is equal to e power cos alpha x. We are writing fd of y is equal to e x power m into cos alpha x. In that case, we remember that e power alpha x is equal to cos alpha x plus I sin alpha x. By that, cos alpha x is equal to real part of e power I alpha x. Sin alpha x is equal to imaginary part of e power alpha x. Then we can write cos alpha x is equal to real part of e power alpha I alpha x. Now we can rewrite as real part of 1 by f of d into 1 by f of d into x power m into e power alpha x. By exponential shifting we have this can be written as real part of e power I alpha x 1 by f of d plus I alpha x power m. Then similarly, if you have fd of y is equal to x power m into sin alpha x, then x power m into imaginary part of e power alpha x. We know that particular integral is 1 by f of d into x power m into imaginary part of e power alpha x. Imaginary part of 1 by f of d into x power m into e power alpha I alpha x. Imaginary part of e power of I alpha x 1 by exponential shifting, which is the 1 by f of d plus I alpha into v. Now we are doing the one problem relating to the non-homogeneous linear differential equation. The problem is d square minus 2d plus 1 of y. 2d plus 1 of y. 1 of y is equal to x square e power 2x minus sin 2x plus 3. Sin 2x plus 3. Solution, it is in the form fd of y is equal to x, where x is equal to x square e power minus 2x plus sin 2x plus 3. We write x is equal to v1 plus v2 plus v3. Finding complementary function. Consider the differential equation d square minus 2d plus 1 of y is equal to 0. Auxiliary equation y square minus 2d plus 1 of y is equal to 0. Replace d by m. We get m square minus 2m plus 1 equal to 0. M minus 1 whole square equal to 0. M is equal to 1, 1. Roots are real and equal. Then complementary function is c1 plus c2x e power x. Finding particular integral, where we know that fd of y is equal to capital X, where x is equal to v1 plus v2 plus v3, where v1 is equal to x square e power 2x, v2 is equal to sin 2x, v3 is equal to 3. Then particular integral we write to the v1, v2, v3. So 1 by f of d into v1 particular integral, 1 by f of d into v2 particular integral, 1 by f of d into v3 particular integral. Those we can write as pi1 plus pi2 plus pi3. Finding pi1, 1 by d square minus 2d plus 1 x square e power 2x. It is in the form of e power alpha x into the form. By exponential shifting we have e power alpha x 1 by f of d plus alpha into x square. So e power 2x 1 by d plus 2x square. So d plus 2 is equal to, we know the value of d plus 2 whole square minus 2 into d plus 2 into x square. E power 2x 1 by d square plus 4d minus 2d minus 4 plus 2. E power 2x 1 by d square plus 2d plus 2x square. It is in the form of x power m. Now we can write into the form of 1 plus d whole power minus m. E power 2x into 1 by 2 into d square plus 2d by 2 whole power of minus 1 into x square. So x square form is there, so we can write m is equal to d square plus 2d by 2. 1 by 2 plus 1 by m minus 1. It is the 1 minus m plus m square x square. X square minus mx square plus m square of x square. We are writing all the values one by one. First mx square. M is equal to d square plus 2d by 2x square. So it is 2 by 2. D square of x square is 2 2d by 2 d2 by 2 d of x square 2. So the value is 1 plus 2 square m square x square d square plus 2d by 2 whole square x square d power 4 4d square 4d cube by 4 x square. By doing the value, it is equal to 2. So substituting all the values, pi1 is equal to e power 2x by 2 x square minus 1 into plus 2x plus 2. Then we come to the value pi2 1 by f of d into sin 2x 1 by d square plus 2d plus 1 into sin 2x. Replace d square by minus alpha square minus 2 square, we get 1 by minus 4 plus 2d plus 1 sin 2x. pi2 is equal to 1 by 2d minus 3. 1 by 2d minus 3 into sin 2x. Multiplying divide by, to find the answer of pi2, multiply divide by its conjugate, we get 2d plus 3 by 4d square minus 9 into sin 2x. So 2d plus 3 by 4 into 4 is the sin 2x. So the value is equal to minus 25. 4 cos 2x, 4 cos 2x plus 3 sin 2x. So it is the value of pi2. Then we have the another particular integral pi3, 1 by f of d into v3, 1 by d square plus 2d plus 1 3 into e power 0x, 0 replaced by d. So 1 by 0 plus 1 3 into e power 0x. Finally the answer is 3. So pi is equal to pi1 minus pi2 plus pi3. This is pi1 value, this is pi2 value, this is pi3 value. Substituting all the values, then we can find the solution, general solution y is equal to complementary function particular integral. Because of it is the solution of non-homogeneous linear differential equation. So the complementary function is c1 plus c2x e power x, pi1 plus pi2 plus pi3. Next we are knowing about the LR circuits and LCR circuits. L means inductance, R means resistance, C means capacitor. And in this, with inductance, we see the voltage drop. Voltage drop across resistance is Ri. Voltage drop across inductance is L di by dt. Voltage drop across capacitance is Q by C. Now we apply the Kirchhoff laws to the electric circuit. According to Kirchhoff law, is the algebraic sum of the voltage drops is equal to the resultant electromotive force in the circuit. So we are writing the LR circuit. The LR circuit is given by the L di by dt plus Ri is equal to E. So the voltage drops of the L and R equal to the electromotive force. So the differential equation formed is L di by dt plus Ri is equal to E. So di by dt plus Ri by L is equal to E by L, which is a linear equation. P is equal to R by L, Q is equal to E by L. Integrating factor I is equal to e power p dt, e power r by L dt, e power rt by L. The solution is I into integrating factor is equal to integral of q into integrating factor dt plus c. So r by L, e by L, e power of r by dt by L, rt by L dt plus c. So cancelling the values, the value is e by r, e power rt by L plus c. Now here the constant c is required. So finding c. At time t equal to 0, the current is 0. So 0 into 0 is equal to e by L plus c. So 0 into 1 0. So E is equal to E by R. E by R. So I is equal to C E by R plus C is equal to minus E by R, e power minus RT by L. So finding the current in LR circuit is I is equal to E by R 1 minus e power RT by L. The next circuit is LCR circuit. It is given by the differential equation L d square q by dt square R dq by dt plus q by c is equal to 0. Dividing by L, we get d square q by dt square plus R by L dq by dt plus q by c square equal to 0. R by L is equal to lambda, 1 by CL equal to mu square. Then you have dq square q by dt square plus 2 lambda dq by dt plus mu square q is equal to 0. It is given by the differential equation d squared plus 2 lambda d plus mu square of q is equal to 0. Replace d by m, then you can get m square plus 2 lambda m plus mu square equal to 0. So this auxiliary equation solve, then to give the m value is equal to minus lambda plus or minus lambda square and mu square. If it has the two roots m1 m2, one root is minus lambda plus another root is minus lambda minus. If the roots are real and different, then complementary function is c1 e power m1t plus c2 e power m2t. Then the complementary function is, if the roots are equal, c1 m1 is equal to m2, then complementary function is c1 plus c2t e power minus lambda t. If lambda less than mu, lambda square less than mu square, lambda square mu square less than 0, then it is the I lambda, I alpha. Then e power complement e power minus lambda t, c1 cos alpha t plus c2 sin alpha t. Okay friends, with this we have completed the first unit and second unit of the second unit of the chapters. We have completed the first unit chapter and second unit chapter. Okay, so kindly subscribe our channel and give your I request your comments.